Okay, so a natural log can be written as a log with the base e. So that's what a natural log is. A natural log is a log with the base e. And whenever you have an equation that has only a log on one side, we have to rewrite it. So when I do my rewrite, it would be e to the power e, the base is e, my exponent is 4, and it equals 5x plus 1. So it's e to the 4th equals 5x plus 1. So a natural log is a log with a base e. That's what it is. It's a log with a base e. So natural log is a log with a base e. All right, so now we're going to solve for x. So my next step would be to subtract the 1. So that would be e to the 4th minus 1 equals 5x. And then your last step would be to divide both sides by 5. So it would be perfectly okay. I'm going to write on the on the left. If you wrote your answer as x equals e to the 4th minus 1 over 5. That is what we call the exact answer. Okay, but I want you to also practice typing this in your calculator. So to type an e in your calculator, you have to hit the second function first, which is the green key. And when you hit the green key, you hit the green key ln, and you should get an e to the power of 4, arrow out of the exponent, minus 1. And then I usually hit enter and then divide by 5. So the approximate answer would be 10.72. Yes. So you probably didn't type it in right. So if you didn't get that, I can help you type it in. Did you get that? E to the 4 minus 1. Oh, did I type it in?
You don't do it right. You have to put it down to the next one.
Oh, I just typed it in. What sheet did I type? Oh, yeah, that's what, yeah, you did. You have to get it out, so you're in the exponent. So what you have to do is you have to type in, I was like, all right, so what you have to do is you have to hit the second function, E. So second function, E equals 4. You got an arrow out of the exponent, so you can't put it all in one step. So you have to either use the fraction button. You have to use the fraction button. You can't just put it all in one step like that. Anybody else not get it? So on the test, which is a week from today, wow. I would take either answer. This would be okay. And this would be okay. So you don't have to give me the decimal answer. If you want to just leave it as the exact answer, that is fine. All right, go ahead and copy down this next example. That sun is bright.
Are you looking for your forte or just neighbor?
I think all three of us. So this is the first equation that we're solving that has a property. We have a log property that we have to include. So we need to condense the left. How do you condense addition? Multiplication. So I'm going to condense it down to x times x minus 4. So it becomes the log base 2 of x times x minus 4 equals 5. And now we're going to distribute the x. Which would be the log base 2 of x squared minus 4x equals 5. So we only have a log on one side, so we need to do a rewrite. And when you rewrite it, it would be 2 to the power of 5 equals x squared minus 4x. Two to the power of 5 is 32. So this is a quadratic, so we got to set it equal to 0. So 0 equals x squared minus 4x minus 32. All right, so let's go ahead and factor that down. Find your two numbers that multiply to be negative 32 and add to negative 4. So don't say it out loud. Go ahead and finish factoring and solving that out. So what would be our numbers that multiply to be negative 32 and add to negative 4? Negative 8 and positive 4. So that means that our possible solutions are x equals 8 and x equals negative 4. But we need to do a check. And when I say do a check, what I mean is we have to be sure that these two sets where I have my log are positive. So let's check the first one. When I substitute an 8 here, that's positive, so that's okay. And when I put the 8 here, is 8 minus 4 positive? All right, so that means that this is a go. We can keep this one. That's good. Now let's check the negative 4. So it's already a no-go when I put that negative 4 right here, because you cannot take the log base 2 of a negative. And then if I put it in this parentheses, negative 4 minus 8 is also negative. So this is what we call an extraneous root. We have to cross that out. We can't keep that one. So there's only one solution that's going to work. We only have to worry about that for a log equations, because remember, the graph of a log looks like the letter R, and it has a domain from h to infinity. It's not like an exponential that has a log of all real numbers. So we have to make sure that our answer does not go past our restriction or past the vertical asymptote. And that's why we have a extraneous root. All right, 2 down, 4 to go. Let's look at number 3 and 4. Go ahead and copy. We'll just do one at a time, because this one might take a little bit more space. So let's go ahead and copy down this one. Well, I think the one on the left is going to take a little bit more space, so I was just going to say copy one at a time, but it's up to you. Okay, so for this one, we have a subtraction sign. How do we condense subtraction? Division, good. So I'm going to write it as a fraction. This is going to go in the numerator. What's in front of the subtraction is in the numerator. What's after the subtraction is in your denominator. So it's going to be written as the log base 5. And then you have your fraction, and it's x plus 1 in the top over x, and that equals 2. So now you're ready to do a rewrite. And when you rewrite it, it would be 5 to the power of 2 equals x plus 1 over x. I'm going to write that as a fraction. Go ahead, 5 squared is 25. So then that gives us 25 equals x plus 1 over x. And I think it's easier to just make that a proportion. Go ahead and cross multiply and solve that for x. So when I cross multiply, that would be 25 times x, and then we go this way, so that would be 25x equals x plus 1. Subtract the x from both sides, so 24x equals 1, and x actually equals 1 over 24. So we need to do a check though and make sure that that's going to be okay. So when we do our check, I'm just checking that this is positive and that this is positive, or I highlighted it. So if I put a positive, 1 over 24 is positive. So a positive number plus 1 is going to be positive. So it's going to be okay for this one. So positive 1 over 24 plus 1, that's going to be okay. And we can take the log base 5 of a positive 1 over 24. So that means that this is actually going to be a legit answer that we can keep. It's not extraneous. And that is my solution. So we have to take the log of a positive number. All right, so let's go ahead and copy down the second one if you haven't already. And this one is actually a lot easier to do because we can rewrite this with a common base after we divide the 5. So I'll give you a minute to copy that one down. We only have a couple more and we are finished for today. No, thank you. Okay, so let's go ahead and do that. So the first thing we want to do is isolate this exponential term. So to do that, this 5 is being multiplied by that 4, so we're going to divide both sides by 5. And then after we do that, I didn't realize that we actually have an equation, an exponential equation where we can write with a common base. Because I can easily rewrite this 4 with a base 2. So I don't need to use a log in this equation. If we can rewrite with a common base, let's just do that. It's way easier. So instead of 4, I'm going to write that as what? 2 to the second. So it'll be 2 equals 2 squared. And then x plus 1. Now, right now, this 2 does not have a power. But what is the power that's right here? 1. Let's go ahead and write that in. So when you cross out the base, I'm left with 1 equals 2 times x plus 1. Go ahead and solve that. Okay, so we have 1 equals 2x plus 2. Then I'm going to subtract the 2. So negative 1 equals 2x. Divide by 2. Negative 1/2 equals x. Now, let me zoom out. This is not a log equation. Does everyone see that? The word log does not appear in this equation. So we don't have to worry about extraneous roots. Exponential equations, if we go back to the graphs when we graphed our exponentials have a domain of all real numbers. So I can use any number in the exponent. I could take 4 to the power of any number. So the checking for extraneous roots does not apply for this particular equation. It has to have a log in it for us to consider that. Yes.
Okay, so 2 to the first, is that not 2?
Yes.
So you got 1.
So what I did was I dropped the base. So after I rewrote it with a common base, remember
we used the 1 and 2.
we dropped the base and set the exponents equal to each other.
Okay.
All right, just a couple more equations and we are done. These are our last 2, I believe. Yeah, last 2. All right, so let's go ahead and copy down 7 equals 5 to the power of x. That's a really short equation. And then the second one is a little bit longer. This one does not take a lot of space. So that's why I would say just copy this one down and then we'll copy this one down last. Okay, so we can't rewrite a 7 and a 5 with a common base. So there is no way for me to rewrite these numbers with a common base. This is when we have to use a log. So when you come into this situation where you cannot rewrite it with a common base, we have to put a log in on both sides. It doesn't matter which log you use. You can use a common log or a natural log. I'm going to use a common log. I'm going to put a common log in. So I have the log of 7 equals the log of 5 to the power of x. When I do that, the reason why I'm putting in the log is because once I put in the log, I can use my third property, which says I can move my exponent to the front. So I can't solve for x as long as it is flying in the sky as an exponent. I need that x to come down. So that x is going to move to the front. Yes, Georgia?
Can you write it in like exponential form first? Like where you do it like base, like log 5.
Yeah, you could do that. And if you had, so yeah, we could do it that way too. So if you did a rewrite, you would write it as log base 5 of 7 equals x, and then you would do the change base formula. So you would get the same answer. So if I continue this first method, we move that x to the front, and we would have the log of 7 equals x times the log of 5. And then I'm dividing both sides by log of 5, which is going to get us to exactly where Georgia would be, because even if you did a rewrite, I would have to do a change base. I would have to take the log of 7 and divide it by the log of the base, which is exactly what I'm doing right here. So either way, we're going to end up at the same place. So you're going to type in x equals, and it's going to be the log of 7 divided by the log of 5. Or you can also do the natural log of 7 divided by the natural log of 5. both of them give you the same answer. I'm going to go ahead and write that down here because I don't know if you can see that on the gray. So you can type in log 7 divided by log 5 or natural log 7 divided by natural log 5. So when you type that in your calculator, and again, you can use natural log or common log. They both give you the same answer. You get x equals 1.209. So that means that if we go back to our original question, 5 to the power of 1.209 is 7. It's really, really close to 7. So you can actually type that in your calculator to verify that. If you type in 5 and hit the exponent key, 1.209, it's going to get really, really close. So I got 6.999. Yes, Deborah. Yep. So on the test, you just have to. If it doesn't say where to round it, then I'm not going to count off. But if it says round to the thousands place, or to the hundreds place, or to the tens place, just follow the directions. Kimmy, did you have a question?
Yeah. Do we have to? Are we able to leave it as log 7?
Yep.
or log over 5?
You can also just leave it as log 7 over log 5. You do not have to give me the decimal answer. Or you could say natural log 7 over natural log 5. The only way I would take off is if you wrote it as the natural log of 7/5. That's not the same thing. Okay. You can't just, it has to be written as a fraction with the natural log of 7 divided by the natural log of 5. All right, this is our last question. Go ahead, copy it down. Does anyone need, because I'm going to need a lot of space for this last question. So before I erase all of this, does anybody still need this? All right, so go ahead and copy this one down. This will be our last question for the week. All right, so I have the log base 6 of x plus 5 plus the log base 6 of x minus 4. How do you condense that down? That's the first thing you want to do. If you see a question on the test next Friday where it's 2 logs, you have to condense first. If they're being added, that means we multiply it. If they're being subtracted, then we make it a fraction. This is added, so we're going to multiply it. So that's going to give us the log base 6 of x plus 5 times x minus 4 equals 2. All right, so let's go ahead and make a box. I'm going to do it over here because we need to multiply this out. We need to multiply these together. So make your box, multiply the x plus 5 times the x minus 4. So that would be x squared, 5x, negative 4x, and negative 20. So that's going to give us the log base 6 of, and then we combine our like terms, so that would be x squared plus x minus 20 equals 2. All right, so now we're going to do a rewrite because we only have one log. So when I rewrite it, it would be 6 to the power of what?
2.
2 equals x squared plus x minus 20, which is 36. So we have a quadratic, so we need to set it equal to 0. So I'm going to subtract 36. So I'm subtracting this 36 from the negative 20. So 0 equals x squared plus x minus 56. All right, go ahead, factor that down. Factor and solve it. All right, what are our two numbers that would multiply to be a negative 56, but add to a positive 1? Negative 8 and 7?
Negative 7.
Negative 7, positive 8. So we got a negative 7 and a positive 8. So x equals 7 and x equals negative 8. Now this is a log equation though, so let me zoom out. Which means that we have to be sure that we can use them both. So what I have highlighted, these two bubbles have to be positive. They have to be positive. So if I put a 7, a positive 7 here, 7 plus 5 is positive, 7 minus 4 is positive. So 7 is cool. We can keep 7. I'm gonna keep that 7. That's good. But the negative 8, when I put my negative 8 right here, negative 8 plus 5 is a negative 3. That's a no-go. Negative 8 minus 4 is negative 12. That is a no-go. So this one is thrown out. That's extraneous. So we're going to cross that out. And that's all you have to do on the test. You have to circle it if it's a keeper, cross it out if we got to throw it out.